Hey guys, just going to work on the second part here. So looking at exponents, remember the rules. If you are multiplying exponents with the same base, I think everything we do here has the same base, so you don't have to worry about that too much. But if they have the same base and you're multiplying, you're going to add the exponents. So that's how you get that. 2 plus 3 is 5, and then you can just put that in your calculator, 3 to the 5. When you have coefficients in the front here, so the 4 and the 3, it's the same thing as over here, kind of. The base here, the exponent, this is a little confusing, I guess. The exponent is on the p, not on the number itself, not on the 4 and the 3. So the p is what's going to have the exponent rule applied to it. So you have the 5 and the 3, they're being multiplied. So again, as they're being multiplied, you add the exponents. So the 5 and the 3 are added to get 8. And then what you do here is, that's kind of weird. Then I'll pop it up. 4 times 3 is 12, and that's how you get the 12 in front. So just worry about the rules on on what has exponent on it here. The m doesn't have an exponent, so when there's no exponent, it's a 1. So you're going to add a 1 and a 2. Oh, I messed it up. 1 and a 2. That's a 2, and then you'll get 3 here. Okay, and then you just multiply the coefficients. 7 times 8, 56, but it's negative 7, so your answer is negative 56. This is division. So the first three were multiplication. When you multiply, you add. When you divide, you subtract. So 5 and 2, 5 subtract 2 is 3. That's how you get this. And then 8 divided by 2 is 4. That's how you get that. So there's your answer there. Another division question here. I like to write it like this, to tell you the truth. But then you go 18 divided by 3 is 6. And you go 5 subtract 4 is 1. You can also write it like this, because 6 to the x is the same as 6 to the x to the 1. Or 6 times x. 6x is the same as 6x to the 1. Power of a power, so you have an exponent on an exponent, and what you're going to do is you're going to multiply here. So the 6 and the 2 multiply to get the 12, but you do have to be careful. If there's a number inside the bracket, you must also apply the exponent power to that number. So the 5 also gets squared to get 25. So 5 times 5 is 25. W6, so this is W6 all squared. And in that case, you're going to multiply like that to get 12. Okay, so that's the first page on this guy. And those are your answers. Collecting like terms. You have 8K, you have 7K, or subtract 7K, and you end up with 1K there. So you just don't touch the variables. Just see how the coefficients play out. So here I have -7, -6. So I always think of temperature, always. I probably said that before to you guys. -7 out, it goes down 6 degrees. You're at -13 degrees, -13 P. Over here, you're going to collect like terms. So you got to make sure that the terms that you're collecting are the same. So here you have a number or a constant, right? So just you have a whole number, 2, and you have -8. So they turn into -6. 5x is by itself. Just leave it as that. You can't do anything after that fact. Here you say I have -8r, I have +8r, and those turn into 0r. So I didn't write that here, but 0r would go here. And then I just have the 7 left over. If there's a bracket outside, so in this class here, in this section of the class here, we're just going to look at binomials. So there's 2 terms, we're going to add them together or subtract them. So you just got to be careful. If there's an addition here, all you do is open up the bracket. So anytime there's a bracket and there's something in front of it, you multiply the bracket by everything outside the bracket. So over here, I'm just going to jump. Over here, you have a 4, so you're going to multiply everything by 4. Here you have nothing in front, which is just a 1 or a +1. So when you open the bracket, you don't have to do anything. You just open it up. Same with this. This is plus, which is really +1. So what would 1 times this and 1 times that be? That would leave them the same as they are, right? So 2p squared stays as 2p squared. -5 is -5. Then you collect like terms. There's -3p and there's +2p squared. They're not the same, so you can't do anything with them. Okay, so p and p squared are different, so you can't do anything with them. The only like terms are the 4 and the -5, and they turn out to be -1. So I rewrote it this way with the p squared first. You don't have to, but I have 2p squared -3p -1. Here you got the first bracket with nothing there. Okay, you have nothing in front of it, so when you open it up, it just leaves it as is. And the second one has a negative in front, so that's a -1. So you have to multiply everything by -1 or change the sign. So this becomes -4v cubed, and that becomes +5v squared. Then you collect like terms. I have a v cubed, I have minus 4v cubed, so that's minus 5v cubed. So minus 1 minus 4 is minus 5 of these guys. I have 5v squared, but I had 2 other v squared over here. That turns into this, and then I had the 3 at the end there. So again, when there's a bracket, you open it up. There's something in front of it. You multiply everything in the bracket by what's outside. So 4 times 4 is 16. 4 times 6 is 24, and you have the a there. Same with this, but now you have r times 6r, so that'd be 6r squared, and that'll be minus 3 times r, which is minus 3r. And the same thing for the next two. You're going to multiply 2n squared times 5 to get 10n squared. You're going to multiply 2n squared times 10n. So 2 times 10 is 20. N times n squared is n cubed. And same with this. You just got to be careful with your signs here. So my writing's not the best, but minus 4 times minus 3 is going to be plus 12. And then p squared times p3. You're going to multiply these together. So you're going to add the coefficients, or sorry, the exponents. So you're multiplying the p squared and the p cubed. 2 plus 3 is 5. And then here you're going to add the 2 plus the 1 to get the 3. And minus 4 times plus 5 is minus 20. And then you do the same thing with the last part here. But then at the end, you collect like terms if it's possible. So when I finish multiplying this, I have a minus 7 and a minus 20. I can put those together to be minus 27. And all I did on the last step was rearrange them to have the x first, which is usually what we do. We try to go for like x squared, then x's, and then constants, and keep going. So the bigger the number, or the bigger the order, it goes first. But not that important. Minus 8n here, and then this is minus 8 times 6, which is minus 48. Minus 8 times minus 4n. That'll get you 32, plus 32, because there's 2 negatives, but there's an n also. Then you collect the terms. There's minus 8, there's plus 32. That's 24n. And there's your answers. And the last bit for this section here are solving equations. So now we're going to find out what x is. So some of the same rules apply later on as with what we've been doing lately. But what you want to do is at the end, your goal is to have x equals something, okay? And how to do that is to move everything across or away from the x. So here I have minus 5. So to get rid of the minus 5, I add 5 to both sides. When I do that, I have 3x equals 12. Then I have 3x equals 12. I divide by 3. That's what this says here. To get rid of the 3. So to get rid of this 3, I divide by 3. And then I have to divide that by 3, and x is 4. Over here, I'm going to leave the x's on this side. I'm going to take this constant and move it over. So it's minus 5 here. It's, sorry, plus 5 here. It's minus 5 here. So I have 6x minus 4x, which is 2x, equals minus 3, subtract 5, which is minus 8. Then you divide these out, and it's negative 4. Get the wrong answer there. Minus 4. In this case, you have the variables on one side, so 2x on that side, x on that side. You bring that one over. So 2x, and this x was by itself here, so I bring it over, it becomes minus x. This is 3, I bring it over, it becomes minus 3. And then I'm just left with 2x minus x is x, minus 6 minus 3 is minus 9. Same sort of thing here. I bring this 2x over, it becomes minus 2x. I bring this 9 over, it becomes plus 9. I put these together to get 15. I put these together to get 3, and then I have to divide by 3. I did a check here. You can do the check at any time. So what you do is you go back and you sub this 5 into the left side, and then you sub it into the right side. So anywhere you see an x, you put the 5, sorry. So 5 times 5 is 25, subtract 9 is 16. 5 times 2, or 2 times 5 is 10, plus 6 is 16. They're equal, which is great because that's what you want. The last thing is just subbing in. So anywhere you see an x, you put the 3, and then you just work your way through it. And here, same thing here. Anywhere you see an a, you put a 3. But also we have a second thing, which is b is 4. The last step here is c squared is 25. You want to take the square root to get rid of that. This is a Pythagorean theorem type question. And that's it. So I hope that makes sense. And take care.